We're going to start this section here called linear equations. So we're going to learn how to solve linear equations, and at the end of this I'll do some absolute value equations. Before we get going, let me show you some properties here just so you can know. These are the properties we're going to use to solve equations. So if two things are equal, like let's suppose A equals B, then if you add the same thing to both sides, then you'll still have an equal or an equality. So if A equals B, then A plus C equals B plus C, and where C can be any real number. So an example of that would be right here. So here you have x minus 2 equal 3. So that's kind of like the A is the x minus 2 and the 3 is the B. So what you want to do is figure out a way to get the x isolated by itself. So you can see here that if you were to add 2 to negative 2, it would cancel. So basically I'm going to take the left hand side of the equation and add 2 so that the 2's will cancel, and then I'll just have x. And I can add that 2 as long as I add the same number to the other side, because that's where this property comes in. If you add c to the left, you also have to add c to the right. So in that case, if I add 3 plus 2, then I get x equal 5 for the answer. Okay, since c could also be a negative number, it also holds for subtraction. So if A equals B, then A minus C equals B minus C. So that would come into play if you had x plus a number. And then if you had x plus a number, you could actually subtract that number from this side. So we can subtract 2 from x plus 2, and then we would get 2 minus 2, which is of course 0, so they would cancel out. And then on the right hand side we would also subtract 2, so we would get 3 minus 2, which is 1. And by the way, you can check these. Just plug the number back into the equation and make sure it gives you a true statement. Alright, now there's also a multiplicative property here. If A equals B, then A times C equals B times C. Again, where C is any real number, well, except 0. C can't be 0. Okay, so if you have a variable divided by a number, like y divided by 5, equal to another number, say negative 3. Well, one way to get rid of this 5 in the denominator is just to multiply this expression by 5. Because when you multiply, then 5 divided by 5 is 1. So you really just have 1y here. And 1y is just y. Now, if I multiply the left side of the equation by 5, I also have to multiply the right side by 5. That's what this property tells me. That if you multiply the left side by c, you got to multiply the right side by c. So in this case, c is 5. So I'm going to multiply 5 times negative 3 and get that y equals negative 15. You can also apply a division property. If A equals B, then A divided by C equals B divided by C, where C is any real number except 0, because you can't divide by 0. Okay, so if I had 5y equal 25, then the way to get the y by itself would be to simply take the 5y and divide that side by 5. So if I divide that side by 5, then I get what I had over there on the previous problem. I get 5 over 5, which is just 1, and 1y is the same as y. And of course, if I divide the left hand side by 5, I must also divide the right hand side by 5, and I get 25 divided by 5, which is 5. Now sometimes it might come into play that you, instead of dividing both sides by c, you might just multiply by 1 over c. So I like to think of that like if I have a fraction over here, because some students get confused about how to divide a fraction by 3. So rather than divide both sides by 3, here you can think of this, it's the same thing, dividing by 3 is the same thing as multiplying both sides by 1/3. So here, if I have 3x and I wanted to eliminate that 3, then I could just multiply 3x times 3, and then of course 1/3 times 3, that's just going to be 1, so that gives me 1x. And then on the right hand side, I'm going to multiply this fraction by 1/3, and so that's going to give me 2 over 3 times 5, 2 over 15. Now I want to show you one more example that you might do, and that's when you have a fraction with the variable over here. And this is a little trick you can do to eliminate this fraction. If you multiply a fraction by its reciprocal, just flip it over. So if you have 3/4 and if you multiply it by 4/3, then 4/3 times 3/4 is simply just 1. So there you would just get 1x. And of course, if you're going to multiply this side by 4/3, you also have to multiply the right hand side by 4/3. And you can do this the long way. 4 times 12 is 48, then divided by 3 is 16. Or you can do a little shortcut. 3 goes into 12 4 times, and that gives me 4 times 4, which is 16. Okay, so now I'm going to go into these one-step equations, and on these first ones, since I've already shown you some examples, I'm not going to spend a lot of time on these first ones. Okay, so here I have to solve x plus 7 equals 9. So to eliminate the 7 from the x, I can just subtract 7 from both sides. And when you subtract 7 from both sides, over here it's going to cancel the 7, and so all you have left is the x. And on the right hand side, 9 minus 7 leaves you with 2. Here I have a minus 5 equals negative 2. So what I can do here is add 5 to both sides. If I add 5 to both sides, I'm choosing to add 5 so that it'll cancel this negative 5. And so that tells me I must add 5 over here. So I get a on the left and 3 on the right. So the answer would be a equals 3. Here's similar to number 1. It's actually just like number 1 except for the number on the right. But I turned it around for you. So here you have 7 plus x instead of x plus 7 equals negative 11. Well, still I can subtract 7 over here so that 7 minus 7 cancels. And then over here I subtract 7 as well, and negative 11 minus 7 is negative 18. Okay, now number 4 here, I've got a number multiplied by the variable. So to isolate the variable, I just divide both sides by that number. So if I divide 3p by 3, then 3 over 3, remember, is 1. So that just gives me 1p, which is just p. And then I have to divide negative 45 divided by 3, and negative 45 divided by 3 is negative 15. On this one, I have x over 5 equals 12. And so what I need to do here is multiply both sides by 5, so that this 5 here will cancel with this 5. And when I say cancel, I mean 5 over 5 equals 1. So I get 1x here. And then on the other side, I'm going to multiply 5 times 12 to get 60. All right, now when you have a negative over here, whether it's a negative number divided in a division or multiplication, what you want to do is you're going to multiply by 5 so it cancels the 5. But you want the sign to be positive. So we know, since we know a negative times a negative is a positive, we're actually going to multiply both sides by negative 5. That way we know that when I multiply the negative times the negative, I get a positive value, rather than a negative value. And we know the fives actually cancel here. And so I'm just going to get t on the left. And then since I multiplied the left by negative 5, multiply the right by negative 5, and I get negative 5 times negative 8 is positive 40. So make sure you're familiar with your signs, operations of signs. Okay, now this next one, since I'm multiplying by negative 3 times z here, and I want to solve for z, I actually have to divide both sides by a negative 3. If I just divided by 3, it would cancel the 3, but it would still leave me with a negative. But if I divide this by negative 3, then it's going to give me positive z for the answer. Okay, so that would give me z on the left, and then if I divide 35 by negative 3, I get negative 35 over 3, because a positive divided by negative, remember, is a negative number. Now, since 3 doesn't go into 35 evenly, I'm just going to leave it like this as an improper fraction. But there's other ways you could write that. Depends on your instructor on whether he wants you to write it or she wants you to write it. You know, you could divide 3 into that and say, okay, well, 3 goes into that 11 times with a remainder of 2. So, you know, you could write that as negative 11 2/3, or you could even write it as a decimal if that's okay with your instructor. Okay, so here is another one, kind of like the one I had on number 6 here. I'm dividing by 7, so in order to eliminate the 7, I have to multiply by 7. But since I have a negative here, I've actually got to multiply by negative 7, so that when I multiply the negative times the negative, I get a plus x rather than a minus x. So if I multiply the left side by negative 7, I must also multiply the right side by negative 7, and negative 7 times negative 3 is 21. Okay, now I have one more here. Negative 8k equals 12. So since I'm multiplied by negative 8 here, then I have to divide by negative 8. So that negative 8 divided by negative 8 turns out to be 1k. And then I have to take 12 and divide it by negative 8. But actually, positive divided by a negative is a negative, so this is going to be a negative fraction. But you can actually reduce 12 over 8. If you divide the top and bottom by 4, 4 goes into 12 3 times, so it gives me 3 in the numerator, and 4 goes into 8 twice, giving me 2 in the denominator. So the final answer would be k equal negative 3/2. Now, all of these, every one of these problems was simply a one-step equation. So I only had to do one step to solve for the unknown in each of these equations. So in the next problem, I'm going to show you how to solve two-step equations in the next set of problems.